Hello, and today's lesson we're looking at securing future mineral supplies. So we're going to look at improved exploratory techniques, improved exploitation methods, and then we're going to look at exploiting low-grade deposits. So to start with then, it's probably worth putting this into a bit of context. So up until this point, we start off by using deposits that are shallow, so they're not very deep. That they are large, so there's large quantities, so you get economies of scale, easily accessed, and high grade. And we use these ones first. As we exploit and exhaust these deposits, we're going to start having to look for less accessible, smaller, deeper, lower grade deposits. But because rising prices are likely to develop as these metals demand increases, this will result in a reduced cut off ore grade, and this means that they will be economically viable. And this is especially true if we have improved technology. Okay, so this will allow us to exploit these low-grade ores. Or more inaccessible due to things like depth, for example. So let's start with this one, improved exploratory techniques. So the first thing we're going to look at is better remote sensing resolution. So resolution refers to the ability to identify between two distinct points. So if we had good resolution, we would be able to see that these two squares are separate and have a gap between them. If we had poor resolution, we would see them as one blurry mass. So we wouldn't really be able to see between the two of them. And this is a concept you'll have come across in biology when you're talking about things like microscopes, for example. So if we have newer satellites, these are going to have improved sensors. And we are going to have more pixels, which means the little squares that make up a picture, per image, because they have a higher resolution. And this will allow us to identify smaller features of interest from a satellite. The other thing that we have on newer satellites is multispectral sensors. So these detect a wide range of wavelengths. So typically, when we're talking about these, this is talking about visible and infrared wavelengths. And this provides us with more detail and more information and allows us to identify the mineral composition of the Earth and lower grade deposits. So there's my satellite. Okay, so he's got a cool new camera system on him. Next one then, portable field equipment. So this is things that allow us to identify features of interest on the ground much more easily. So portable meaning able to carry. And this has been driven by improved batteries, by improved electronics, and these have both got more powerful and lighter. So you get things like infrared spectroscopy, X-ray fluorescence, helps you put the U and the O the right way around there, fluorescence, and radiation detection. This saves time because it's immediate. You don't have to send it off to a lab to get your results, to refine your search. So there's no delay anymore. And that speeds up your search. Oh, and before I get too carried away, I better say some examples. So you've got things like Landsat, which has the visible and infrared sensors, and this does the entire surface of Earth in 16 days. And another one you get is the Terra satellite. And this has an infrared camera on it called the Aster sensor. And now let's go a look at exploration methods. So we found our deposit, now we're dragging it out of the earth. So we have deep mining, where mechanization is important, and mechanization is using machines to do jobs that perhaps people were more deeply involved with in the past. So deep mining, as you go deeper under the earth, and we're talking seriously deep, so we're talking sort of 3.8 kilometers down, we are starting to see issues with heat. So as you get deeper and deeper, the heat starts to build up. And this gets to a point where it's actually dangerous for humans to be exposed to these temperatures for any length of time. And it's also dangerous because you're so far down, if something goes wrong, it's very difficult to get to you. So South Africa has these very deep mines where they dig high value products, things like gold and platinum. So it's too hot and dangerous. So we can use mechanization instead to replace people at that depth to a greater degree. So machines replace humans. The other one then is opencast mining. So we can use larger machines to do our excavations. So we can quickly and efficiently remove overburden and minerals by having larger machines. So we are going to have excavators that are 13,000 tons and trucks that can carry 300 tons at a time. And this allows opencast mines to get deeper to the depth of 600 meters, which was in the past impossible.